Okay, guys, we are here to solve some more problems on algebraic fractions. Now, if you notice the previous examples we did, um, the denominators were just whole numbers. But in this particular question, I decided to make the algebras to be the denominators. As you can see, instead of having, let's say, 2a over something, 2b over something, I said, okay, let's just make so we are simply solving algebraic fractions where the denominators are algebra. Okay, so let's look at how to solve this problem. Now, this type of algebraic fractions are actually called monomial algebraic fraction. Monomial algebraic fraction, as in monomial, because the denominators are just one term. 2a is a single term, 2b is a single term. Okay, I'm going to show you the other ones, the one we call binomial. Okay, where we have binomial as the denominator. That's what we want to do now. Okay, so let's look at that. Let's take the first one. Here we have 1 over 2a plus 1 over 2b. Okay, so what will be the LCM? The LCM of 2a and 2b. Let me show you how to get that. It's just the same way of getting the LCM of numbers. Okay, but since we've not done something like this, I don't think we have. So let's just do this now. How do we get the LCM of numbers? First of all, we are going to divide through each of those numbers, each of those terms, until we have one left. One left on each column. So how do we do that? Let's look for a number that can divide through both of them. Okay, so 2 can divide through. So we are going to get 2a divided by 2, which will give us a. Alright, that's like saying 2 times a divided by 2. So these 2 will cancel 2 and we are left with a. Alright, so 2b divided by 2 will give us b as well. Alright, now let's continue again. What can divide a and what can divide b? There is no particular number that can divide a and b at the same time. Okay, so but we are looking for LCM. So what we just do is to divide using a. A divided by a will give us 1. B divided by a will not work, so we still retain the b. Now we introduce another factor, which is b. 1 divided, this one is just going to be 1, just going to remain as 1. Okay, because it will not work. 1 divided by b will not give us a whole number, so we just leave it as 1. Then b divided by b will give us 1. Okay, so now that we have achieved having 1 on reducing this to 1, reducing this to 1, so what will be the LCM? The LCM is going to be 2 times a times b. 2 times a times b, and the other 2 times a times b will give us 2ab. Alright, so that's the LCM of 2a and 2b. That's how to go about looking for LCM. That's what we've been doing all along. So the LCM is 2ab. So we have this 2ab. Now for us to simplify this problem further, what we need to do, remember I introduced a strategy where we use the denominator here, divide this, and then whatever we get, use it to multiply the numerator. Okay, so the LCM we got is serving as the common denominator of 2a and 2b. So that's why it is like this. So we use the common denominator and divide each of the denominators. So we are going to do 2ab divided by 2a. Okay, when we do that, 2ab divided by 2a, we are going to get that 2 will cancel 2, a will cancel a, because they can both be divided by a. 2 can be divided by 2, which will go. A can be divided by a, which will go. We'll be left with b. So we are left with b when 2ab divides 2a. So that b times 1 gives us b. Then plus, here we have 2b. So we do 2ab divided by 2b. So if we have 2ab to be divided by 2b, 2 will cancel 2 to give us 1. B will cancel b to give us 1. What will be left is a. So we use that a and multiply 1. We are going to get a here. So what we are left with up here is b plus a all over 2ab. Okay, b plus a over 2ab. Now what we have here is the solution to this simplification. We cannot do anything further. We cannot add b to a because they are not alike. They don't represent the same quantity. They cannot represent the same number. Okay, so that's why we cannot add both of them together. So we have b plus a over 2ab as a solution of 1 over 2a plus 1 over 2b. Okay, let's go to the next example. On the next one, we have 2 over 3a minus 1 over b. Please, this is b, not 6. Hope it's end looking like 6. Alright, so that's what we have. So actually getting what we do is the same procedure. We get the LCM of 3a and b. The LCM of 3a and b, if you follow what I just did recently, in the previous example, you're going to get that the LCM will be 3ab. So 3ab divided by 3a. 3ab divided by 3a will give us b. This is what I mean. 3ab divided by 3a. 3 will cancel 3. A will cancel A. We'll be left with what? B. Alright, so b times 2 will give us 2b. Alright, so people often want to write b2. It's not correct to write it this way. It's 2b. Okay, that's the correct way to write it. Then minus 3ab divided by b. 3ab divided by b is going to give us 3ab divided by b. B will cancel b, so we'll be left with 3a. Alright, so 3a times 1 will give us 3a here. Okay, so basically that's all we can do for this problem. There's nothing else we can do. So the solution of 2 over 3a minus 1 over b is equals 2b minus 3a all over 3ab. So this is the simplified form of this same here. Okay, let's go further and look at that guy. Here we have 4 over a multiplying 2 over 3a. Now, the rule in multiplying fractions is that you multiply numerator to numerator, denominator to denominator. Simple, right? So all we are just going to do is that we are going to write this as 4 times 2 all over a times 3a. Oh God. Okay, so we are going to get 4 over a times 2 over 3a, which will be equal to 4 times 2 all over a times 3a. That's what we'll get. So 4 times 2 is simply 8, right? And a times 3a will give us 3a squared. Let me show you. A times 3a, alright, will give us a times a will give us a squared. This is like saying 1a times 3a. So 1 times 3 is 3. A times a is a squared. Alright, so that's why we get 3a squared. So that's the simple form of that. Nothing else can be done further. Okay, so let's go to the next one, where we have 7 over a divided by 14 all over 3a squared. So this is quite simple. This will be equal to 7 over a times 3a squared over 14. Now you can see that in this problem we have a multiplication sign, and you see when we have a multiplication sign, I always advise that you look out for numbers that can cancel, alright, so that you can simplify your problem. So if this is a squared, this is a squared divided by a. If a divides a here, we'll get 1. If a squared is divided by a, we'll get a left. So and again, if you look at this, 7 here is going to be 1, right? And then 14 divided by 7 is going to be 2. So we are left with 1 times 3a all over 2. 1 times 3a is 3a, and 1 times 2 here is 2. So this is the solution to this guy. Alright, so I'm going to wipe this off now so that I can proceed with the solution of the other problems we have here. Okay, so let's take on the fifth problem here. The fifth problem we have here is that we have a over b plus c over d. Okay, a over b plus c over d. A over b plus c over d, we look for the LCM of b and d. LCM of b and d, what would that be equal to? So we look for any factor that can divide b, until we have 1 remaining. So b can divide b, right? B can be divided by b and we'll get 1. D cannot be divided by b, so we have d. Now we'll do d. 1 divided by d will still be 1 because we cannot get a whole number. It's going to remain as a fraction. So d divided by d, we get 1. So the LCM here is going to simply be b times d. So the LCM of b and d is b times d, which is bd. So the LCM here is bd. So what do we do with bd now? We say bd, please follow me, bd divided by b is going to give us d, right? bd divided by b, alright, is going to give us, b will cancel b, we'll be left with d. So d times a will be ad. Then because there is a plus sign here, so we go with the plus sign. And bd divided by d, bd divided by d is going to be, look at this, bd divided by d is going to be b, left with b. So b times c is going to give us what? AC. Alright, so at this point, it's going to give us c, not it's going to give us cb, right? Yeah, b. So bd divided by d will give us b. B times c will give us cb, or we write it as bc. Okay, it is always proper for the alphabets to be written in the order of their occurrence. Like a is always comes before d. Alright, so that's how to do that. So once this is done, you can see this expression. So that's the solution to this problem. We can't do anything further. Alright, so let's take the last one here. The last but not the least here. So where we have x over 2 plus y over 5. Okay, so x over 2 plus y over 5. We look for the LCM of, we've done something like this earlier. X over 2 plus y over 5. The LCM of 2 and 5 is actually 10, right? So 10, let me use the other approach for solving this. So we now use the LCM, which is 10, and multiply each of the fractions so that we have 10 times x over 2 plus 10 times y over 5. You see this, right? So 2 here is going to be 1. 2 into the 10 will be 5. So 5 times x gives us 5x plus, 5 here is going to be 1. 5 into 10 will be 2. 2 times y will give us 2y. All of this divided by 10. Alright, so this is our solution here. Okay, so that's it for these examples. I'm going to come up with some more serious examples. Okay, so just follow me. Thank you.